Amazing, we're recording. Okay, welcome to the 9th weekly. What's it called now? Cyber Sunday. I'm gonna call it Cyber Sunday. And yeah, we're continuing with our web challenges, and hopefully this time we're gonna get to do some new topics, specifically forensics, and maybe a little bit of reverse engineering. But yeah, without further delays, let's start with actually the first challenge. It's not more SQLi. It's not the it's not the first challenge. The first challenge is client side again. I remember in the last session before the break, Ali wanted to do this, but we decided we did not have time, so we're gonna do it now. Okay. Client side again. Yes. Can you break into the super secure portal? Okay. And we're given the link. No files, no nothing. These are the same link. It's fine. Okay. New and improved login. Wow. They even have a powerful background. No need for the classroom now. You can just search in PicoGem the name of the challenge directly, search by name, put client here, it would be client side again. We finished already, don't use client side earlier. So no need for the classroom for now. Okay, it says new and improved login, enter valid credentials to proceed. Okay, I'll definitely not use my actual password, but let's say password 123, incorrect password. And it was like lightning fast, no delay, no nothing. So, and from the name of the challenge and the description, there is probably something to do with client-side authentication, which is a big no-no. But let's validate that. Let's validate. We remember to go to the three dots, and then more tools, and then developer tools. Okay, by default it opens network for me, which is good. So let's see. Is there any network request being done? Nothing. No request. You're on the same website. Yeah, exactly. And so let's see like there has to be some script that's taking in our data and telling us it's incorrect. So we can check it from here, or we can view page source. Same thing. Oh, what do we have here? This is all standard stuff, standard header, and this is the simple body of the website. But then we have this script, which is very long. It's on one line. So, this has to be doing something. It says password verified, incorrect password, again. Oh, and there's even a piece of the flag here. But then, of course, it's not easy to like reverse engineer or just get the flag out of. We see a function with weird hex parameters. We see variables that we cannot read. So it's very, very difficult to just get the flag from this. So as actually the hint for this challenge, it will tell you what is obfuscation. Obfuscation is the process of making your code hard to read. It's the same exact code with the same functionality, but just in a very obscure, difficult to interpret way for the human. But for the machine, it's the same exact code. It will still work. So if we Google JavaScript, the obfuscator, there has to be some tool to do this. No one is gonna by hand change the variable names to hex and change the way the function is being called and so on. So there has to be a tool for doing this, and it's free online. There is multiple online deobfuscators. So let's pick the first one, or the second one, doesn't really matter. So is this the same code? I don't remember. Okay, let's give it the code. It gives us, your code looks like it has been obfuscated using obfuscator.io. Would you like to go to the deobfuscator specific for that? So different obfuscators, they obfuscate the code in different ways. Um, so here this tool detected that it's a different tool. So that's very generous of them to guide us in the wrong, in the right direction. How did you know the code is obfuscated? When you look at it, the names of the variables, how short it is, it's on one line, which is no one's gonna write code on one line. Of course, the hint helps, but when you come across this, you can come across this in normal websites, by the way. It's standard practice to just obfuscate the code just as an extra step. It's not really like the code is now secure and your source code is is protected, but it's an extra step. But you will get used to this one line of JavaScript, weird notations, and here they're calling functions using a dictionary, which is weird to say the least, but that's how you can detect it. Okay, let's follow their advice and go to the other website. And let's paste the code here as well. We're gonna deobfuscate everything because we don't know what they did anyways. Deobfuscate, and we get this. Okay, less worse code. It's not better, it's just less worse. Okay, so the rest will just be us, you could say, reverse engineering this. So I'll open Visual Studio Code, okay, and I'm going to create, okay, I have the flag, so it's a good thing I didn't move it to the other screen. So I just copy pasted what, okay, I just copy pasted what we, we're leaking flags. I guess AO schedule, probably, hopefully. Actually, I think at some point it was not, so I'm not sure if it still is or not. But now we're gonna do a good number of renaming, and let's see how it goes. So this variable, okay, this array, we can rename it to var, okay, as to array, let's say. So in Visual Studio Code, you can hold down, what's the Windows key? I think function key for Windows, and then F2. Oh, just F2, yeah, I just have to. I'm on Mac, okay. Yeah, just F2, and then rename it. It will rename all of the occurrences of that variable. Now, one thing to note here, before we jump into this complicated function, there is this function, we'll get to it later, okay? It's fine. This function. What is happening here? Let's see. This function is being defined and called just once. That's it. It's not even being named. So it's doing something to the parameter. So let's try to break it down. This, what I'm highlighting right here, is the function definition. And then right after it's being defined, it's being called. So let's see what it does with its inputs. So let's say, let's call this, let's rename this to the same as the parameter that was passed. So let's call it array, okay? And this one, frankly, I have no clue what it is, so I'll just call it parameter 2. Okay. This function is defining another function. It's doing pushing and shifting. It's just reordering the array. Okay. Now we can try to actually reverse engineer this and debug it by hand, but honestly, it's much simpler than this. We know that this function runs once, so we know that's going to do its weird shifting just once, and then as soon as the script is ran, and then after that, this is what gets ran, the verify every time you enter the password. Omar, could you repeat after the F2 part that lost what was about? Yeah, so right now we want to focus on one function only because it seems to be changing the order of the elements in this array, okay? So it's easy for us to do this part, okay, by hand. This part not so much. It's not too simple. So what we can do, instead of doing this by hand, we can go to the website itself and get that array after it has been reshuffled. Like this function is just a reshuffling function. So we're going to go get the array and replace it, and then we can continue and we can ignore this function completely. We know that we have the correctly shuffled array. So I hope this will make sense, like when we actually see the array. So we know that the array is called what? Let's go to here, it's clear. This is the array. A weird hex name, but yes, exactly. The dynamic analysis. We're getting the data as the program is running, instead of doing it by hand, which is too difficult. So we see that this is the name of the array. Okay, it's just the name. It looks weird, but it's just a name. Just like we called it ARR, this is just the name here. It's a valid name in JavaScript. So I'm going to go to the console. Can I zoom in? Yeah, oh, nice. Okay, I'm going to go to the console, and I'm going to literally just enter the name of that variable. This will give me the value of it. This is the console. Here you can write JavaScript commands, you can just run JavaScript commands, and it is connected to the JavaScript that's loaded in the website. So that's why it knows the variables there. So if I just write the name of the variable, I get this array. Now let's see, is it the same as the one that we have? No. Here it starts with get element by ID. Here it starts with 37115. So we know that this is the correct array. So now what did we do? We did basically finish this function. It's done. We know the new value. We knew, because it was just reshuffling. Now we have the reshuffled array. Okay, is everything clear so far? Or should I repeat? Oh, Yusuf sent an interesting link. Okay, we need to check that out. Okay, so we now have the reshuffled array. That's it. Basically, we are breaking down the code. We're seeing, okay, I understood what this part is doing to get the flag, so I'll remove it. You know, I remove the reshuffling function. It's an annoyance. Halas, it's done. We know how it was reshuffled. We got the reshuffled array, done. Okay, we have this interesting function here. Okay, let's see. This function, okay, let's break it down from bottom up. Okay, we see it's returning this weird variable. Okay, and this weird variable is nothing but accessing the array at a certain index. Okay, so I'll just call this, I'll rename this to return. Okay, and this is the most useless piece of code. This is taking parameter 1 and -0. That's it. So it's not really doing anything. Okay, so that's good. And then they were trying to throw us off here. This second parameter is never even used. Never used. When I highlight it, it's never to be found. It's just extra. So we can even remove it. Okay, we're not gonna run the code, but let's remove it. So we now have this parameter, and all it's doing, it's just returning the array at that parameter, at that index. So let's actually call it index. That's it. And let's rename this function to a better name than this. Let's just call it access array, because that's all that we're doing. We're just accessing the array. Okay, so whenever we see access array, we know it will be passed one or two parameters, but here it's only being passed one, and that parameter is the index of the element. Okay, now just this part here is what makes JavaScript a very, very interesting language. Okay, before we get to this, like, you see that the function is being passed a string. Okay, why is this allowed? It's just JavaScript. And let's test it. Okay, does it actually work? Sadly, yes. Sadly, it does work. Like if I take this variable, this array, okay, and I go to access element 0, I get element 0. If I go to access element at string 0, I still get the element 0. So let's just forget about the string. It's not really a string. It's not like a dictionary. No, it's just a number. A number that is represented in hex. Okay, hex numbers are basically, for our case, hex is base 16. Okay, so the alphabet goes from, sorry, the numbers go from 0 to F, F representing 15, 0, 0. And for us, it would not be that big of a deal because we barely go beyond 16. So it's not too difficult. Like we can replace it and figure our way around this. So, okay, this is what the document is used for manipulating the HTML of the website itself. So it's not really too big of a deal to us. What it's doing is it's going to the document, it's accessing get element by ID, and then it's passing password. So what this is doing is basically getting our input. This is just user input. Check pass is the user input. Now they're doing it in a convoluted way, but it's just like accessing the user input. What did the user input? So we can check it here because it's check pass like the user input. So I think we can start decoding this. Shall we? Let's go. We see the first. Oh, Ahmed, go ahead.
Thank you. Now, check pass, if I understand correctly, is just like a string with the user input.
Yes, it's whatever we inputted. When I entered password 123, this was check pass.
Okay, makes
We
sense.
can even change it to. I cannot rename. Oh, I think I ruined the JavaScript code too much that it cannot be renamed anymore.
All right, thank you.
Let's check pass. We'll do it the user input. Okay. Oops, wrong. Okay, so let's see. It tells us user input. Okay. Okay, let's decode this part first. So this is just getting the second element of that array. So value. So it's accessing the value because user input, it's getting the HTML element, but not the value of it, not the text. Value just gives us the text. So this is just all of this. You know what? Let's replace it. Let's replace it with just user input. User. Oh, okay, very well done. Yeah, let's replace with user input. So now, of course, the code is not correct, but it's much more readable now. No, oh, yes. Okay, thank you. Yes. I was looking at the wrong index. Yes, it's substring. Okay. This makes more sense. User input is actually a string. Here it's being accessed the first element, the second element of the array. So we're getting the value, but we're calling the substring function. So if you create a string 1, 2, 3, you can access the substring function like this, just like you would do some string dot substring. And then start, end, blah, all of those. So weird, but it works. So yeah, so here, this is just substring. Whenever you see this repeated piece of code, it is nothing but user input dot substring, okay? And I don't even need the parentheses. Okay, let's replace it. Beautiful. Thank you, Ahmed, for that. We would have gone into a loophole, a rabbit hole for like 20 minutes. Okay, so now this is much more readable. It's saying substring from 0 to split. Let's even replace split. Split is just the number 4. Nothing more, nothing less. Split we replace with a number 4. Okay, good. So just one thing to note, if you've done substring in different programming languages, you're used to this, but substring is inclusive of the first parameter and exclusive of the last. So here we're saying 0 to 8, that means 0, 1, 2, 3, 4, 5, 6, 7. You do not include 8, that's it. So let's see. It verifies user input from 0 to 4 to 0 to 8 is this element. So let's just write it. Where is it? 0, 1, 2, 3. Makes sense. Pico CTF. It has to start with Pico CTF. So now we're building the password now. So this is done. Let's remove it. Now you'll find something interesting about this challenge. They are doing redundant checks. Okay, here, let me write actually the index. Oh, amazing. Copilot is very powerful. I'm afraid it will actually autocomplete the flag. So, okay. Let's see. Checking 7 and 8 need to be this. Well, we already know 7. Did I miss something? Wait, what? Yeah, 0, 1, 2, 3, 5, 7. Okay, 7 and 8 need to be this. Okay, so 7 is already there. We're just missing index 8. Okay, so now this is done. So far, so good. We're just following the path, the checks, and we are arranging them accordingly. Here, we want something to, let's say, start around 9. Okay, so this is starting around what? 8. Okay, not bad. So this is from 8 to 2 times 2 is 4. 4 times 4 is 16. Okay, so just replace this. So this is 8 to 16. It's going to be the fifth element. 0, 1, 2, 3, 4, index 4, not this. Okay, but we need to watch out here. This started from 8. So we're going to copy it, excluding the n, because n is the 8. So this makes sense. It's even, let me comment it out so you don't get autocomplete. Okay. So they are just adding overlapping checks just to confuse you. But now we get the trick. Let's see the second check. We have 3 to 6. We already know that this is done. 3 to 6 eco CTF. We can just ignore it. This is from this is later on. So this is 4 times 3, 12 times 2, 24. Yeah. This we can come back to later. We can check this one. 6 to AB, that's 11. We know 6 to 11 is done. So we can just ignore this one. We already finished it. Okay, we're almost done. Here it starts from 16. Okay, amazing. So we know that we stopped at F, which is 15. So immediately after this is going to be this index 5. So 0, 1, 2, 3, 4, 5. No, what? 0, 1, 2, 3, 4, 5. Is it really that element? Oh, sorry. I'm looking at the wrong condition. Yes, it's 6. Yeah. This makes sense. We're looking at this condition. So yeah, it makes sense. And we said it's from index 16, so we just paste it directly because after F is hex 10 or 16. So we can just paste it directly. So now this condition is done. Whew. Now we have this condition. C 216 C, so C 216, this is already done. Yeah, it's pointing us to this. We already know it's done, so we need to do it. We know that from C to 16, so including 15, is done, which is just the word this. So this condition is done. Now Now we can, I mean, I think we can get the last part without even doing this trick, because it needs to end in a closing parentheses. Okay, so we know it's just this part, of course, excluding the 3. But let's double check it. So it says 24. So this is 16, 17, 18, 19, 20, 21, 22, 23. Okay, 24. So without the 3, and that's it. 2 3s. Wait. This is 24, right? This is index 15, 16, 17, 18, 19, 20, 21, 22, 23. Oh, 24. I think the 2 3s, yeah. 2 3s. And now that's the flag. That's it. We submit. If you want, you can even submit it here. Oh, password verified, yes. So we know that it's the correct password. Yeah, 2 3s. Yes, yes, yes. So we submit, and hey, we're done. Okay. Okay, let's start. Let's go to the next challenge. Next challenge, let's switch it up. Okay, we're going to try a Wireshark forensics challenge. Okay. What is Wireshark? What is forensics? This is, we want like just for exposure. I won't focus too much on it. You can easily replicate this later on. But Wireshark is a tool for analyzing network traffic. Okay, so you can see who is connecting to what is the host, source host, destination host, the source port, destination port. You can look at the data. You can even capture traffic on your own computer, for example, when you're communicating with the router, and look at the destination host and so on. Of course, you will not see it in plain text. It depends. For example, if you're on HTTPS, it will be encrypted, and you will not see it unless you get the keys. Okay, but the idea of Wireshark is you analyze network traffic at a very low level. Okay, so we want to see just a new field of the CTFs. So we're giving a PCAP file. This is just a capture file. Like someone recorded a bunch of packets on the network. Okay, they saved it in Wireshark and they shared it with us. So can you find the flag? And Wireshark. There is no hint because it's in the name and then the type of the file. So I download it, okay, and I open it in Wireshark. So what is this? What is this nightmare that we're looking? So this is Wireshark. These are packets, just small pieces of network traffic that are being sent, received. We see the source, we see the destination, we see the protocol, we see the length, we see a lot of info about it. We see even more info about it here. You can even look at the data in hex, like plain binary. Okay, but let's not cover too much. What do we need to know here? We know that web traffic is HTTP or HTTPS, but here it has to be HTTP because otherwise you will not be able to read it. So here is HTTP, and HTTP runs on a protocol called TCP. Okay, now without going into too much details about TCP or the equivalent or the similar protocol to it, UDP, here we'll just focus on HTTP. Why? Because it's the most likely to find a flag in a simple challenge like this. So TCP, think of it as like the boat that will hold HTTP on top of it. It's like a lower level, okay? So we don't need to analyze its traffic. We have the high level traffic, which is HTTP. So we can read that. So like, let's go to an example HTTP request. We click on it, okay. Let me zoom in, okay. We chose this one. This one is a post request. Remember from, I think the first or second session, post request is usually you're sending data. And here we can, okay, how do I, wow. Is it really not going to, okay. Okay, thank you. Thank you, Wireshark. Is it because of my second screen? Okay, I have no clue why I cannot. Oh, okay. Oh, okay, it works. Never mind. Yeah. Let's look at one of the requests. You see, it gives you so much details. Like, to know everything going on here is to be a network magician. So this is like the lowest level, the second lowest level, blah, 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 TCP, as we said, and then Hypertext Transfer Protocol, or HTTP. So as we said, Hypertext Transfer Protocol is running on top of TCP, which is running on top of IPv4, which is running. It's a huge chain. It's a huge layered model. But for now, let's focus on the one that we can actually read, which is HTTP. Okay, we see here, this is an example request. We get everything about the request. We see that it's a post request. We see the headers. We see the content linked, blah, blah, blah. Okay. We see even the data. Okay. And we see everything. Okay. Now let's filter out. This is too much traffic. We have TCP, we said we don't want to look at it. So we go to the top here, apply a display filter, and we do HTTP. That's it. Press enter. Okay, this is better. Now we're only looking at HTTP. Now we see the same subscriptions, whatever, blah, blah, blah. It doesn't seem like it's important. It might be something periodic happening on the computer. You know, the computer always does a lot of frequent, repetitive requests to different services for different reasons. So this is repetitive, okay? There's barely anything changing. And you can even see it's Kerberos. Kerberos has to do with the Windows Active Directory authentication protocol. Not of our concern, but it's just typical traffic, okay? If we keep scrolling down, okay, we will be rewarded, okay, with a different request. Get request, a normal get request. And then we see a response to it, okay? A neat trick in Wireshark is you can right click, you can do this later, right click, and then follow HTTP stream. Okay, beautiful. Now it shows you the entire conversation, okay? And you can even, where is it? Yeah, you can see the entire conversation. So this is the request. Someone wanted to get slash, and then the server sent them this response. Yeah, something's off about the last line. It feels like it's a very simple encoding method. It looks like it's some form of a flag, because you can see curly braces, underscores between the words, probably Pico CTF here, and then a small message with it. So there's a good chance this is our flag. Okay, so let's copy it. But actually, I remember yesterday seeing something interesting as well. Okay, I need to cancel this. HTTP, okay. Okay, was I imagining things or what? There was a slash flag. So this will work, but we'll try to decode it now, but okay, I might have been solving a different challenge or something. That's okay. It doesn't start with Pico CTF, but there's something you notice about it. It feels it's some form of encoding. If you remember the other challenges that we did, this feels like it's probably some form of rotation, okay, where you, let's say A becomes B, B becomes C, and so on. Or maybe A becomes C, so push it 2, you know, this type of rotation. Now, CyberShift is a beautiful tool for this. It has a magic tool that immediately recognizes text, the type of encoding and so on. So we paste it, and Wow, we don't get anything. Thank you, Cyberchef. Let's try, let's try to do it manually. Now, the most common type of rotation is rot 13. Okay, or okay, rot 47 does not work. But no, not this one. There was another one. Brute force. Interesting. Where is the? Okay, that's interesting. But we can even, if you want it to really be decoded for us, this website. This is an interesting website. Allow ads? No, thank you. Where is the decoder? Okay, we give it the text, and it will brute force. It will try the most probable rot 13. Yes, rot 13 worked. Yes. So here it tried 92, 125. It's trying some weird stuff, but it also tried 13, and you can definitely tell that this is our flag. Okay, and we're done. So what's the main takeaway here? The main takeaway here is that networks is scary now. Networks is interesting, and forensics is an interesting topic to get into. You will be, of course, I go back to Wireshark. There is much more complicated stuff. You can have the flag split into separate packets, and you need to decode it, like find a way to read the specific packets, combine them, do stuff on them. So it can really be not complicated, but interesting. uh, yes, filter HTTP. Yes, HTTP dot request. Oops. Request dot path. Oh. URI. I think URI should be. Is there an includes, or what was it called? URI dot path. Oh, okay, yeah. And no matches. Okay. Is this how it works? Okay. Sorry. Equal. Oh, not matches. Oh, sorry. Yeah. Let's. No, not Control Z. Let's go back to HTTP, and we don't want to match.
I think you could do a tilde character for the regex matching.
Ooh, this is matching for or matching not equal.
Let's see how to negate it. I think you can wrap the whole thing with not.
Oh, sorry. And what's the path we want to avoid?
So beginning / WS man.
Actually, we can go for HTTP dot request dot method equal get. Yeah, there's only one get request anyway. So it is that request. Interesting. And then this is the response to the request. Okay. Yeah, I must have been solving a different challenge yesterday. I think that actually happened. But okay, now we got an intro to forensics, very powerful field. Let's try something. Should we do another web, or I think another web? Let's leave GDB for next time. Let's do something that's like finally very interesting in web and not client side. Something where you actually have to write some code. Okay, so more SQLi. Can you find the flag on this website? Additional details will be available after launching your challenge instance. Okay, we launched the instance. So this is an actual. It's weird that I don't have the flag on get request. No, it will be on the response. So right click that packet and then follow the TCP, follow the HTTP stream. You will see in the response the flag. Really? That's. Wasn't it done? This follow. HTTP stream. Yeah, it's this one. Wow. What? Are we getting different? Oh, wait. Which one did I just solve? Did I solve this one or this one?
No, it's correct. It's correct. Ali, you're opening the second GET request. Can you get the Wireshark up again? So there's two GET requests. He followed the second one.
What? How is it not showing now? Okay, yeah. This
So
one.
there's two GET requests.
Yes. This one is an actual legit request. But yeah, I just realized I solved the wrong challenge. They have similar names. I mean, it's fine. The one I did yesterday is different. That's why I'm like... but anyways, let's now go back to SQLi. Okay, so now we have this challenge running. Now let me, because I am in dorms, we have a firewall that does not allow SQL injection payloads in AOS. So, okay, it's using the SOX proxy. Good. So I'm using a proxy. But okay, here, it's the first time that we're actually presented with a proper login screen. So let's say password. I try to log in. Okay, it gives me the SQL query. It tells me username Omar, password was password, and then it gives me the SQL query, select ID from users where password is equal to this and username is equal to that. Beautiful. So they are giving you the full request, so it's ready for injection. It's the most non-blind SQL injection you can have. You have full visibility of the query, everything that's happening. So this is a login query. So what this is doing is it's looking for, most likely, okay, a Boolean response. Yes or no. Does the user exist or no? Okay. Sometimes it will be looking like for the user and returning the user object. Okay, now this is a simple example. No need to get to that complex. We'll get to it later in later challenges. But here, all it's like the application in the backend, all it's looking for is one thing. Is this a valid user or no? Give me a 1 or 0, true or false. When I execute this query, do I get something back or no? I don't care what I get back. I just want to get something back. So this helps us a ton. Now, all we need to do is to make this statement evaluate to true. Okay. Now, I think we did an SQL injection before, but what do you think we can do? Like, what's the first step, at least, in something when you're approaching something like this? Any suggestions? Something to use special characters? That's a very good point. Username, we set it to blank. Or is this an SQL injection? I cannot see. Is it double quotes or 3 single quotes? Injection, yes, injection. We need to inject special characters so we escape the quotes that were inside. Because if I put a special character here, let's say I put a quotation, replace this P with a quotation. Now it's what? Select ID from users where password is equal to nothing. Okay, but then I'm writing valid SQL now. I'm no longer in the input password. I'm typing SQL to the database. So there is a famous payload, okay, where I will just be checking if 1 is equal to 1. Let's see, SQL injection payloads or cheat sheet. Hacktricks is not allowed in AOS. Is this? Oh yeah, this is exactly what we need. See, it's checking or 1. See, it's closing the the quotation, and then sticking or 1 is equal to 1, and then commenting out everything else. This is a comment in SQL, double dash. So it's telling it evaluate to true, because or 1 is equal to 1, of course, is going to evaluate to true, and or looks at one of them being true. So now it's basically this is being ignored because something else is being evaluating to true, and we're going to discard everything else. Let's write the full query in test.sql. Okay, we want our password to be quotation. Yeah, we're going to go through it in detail. So what do we want? We want to escape this and start writing arbitrary SQL code. Okay, so we're going to end this, and then we're going to write, for example, 1 is equal to 1 or 1 is equal to 1. This is going to evaluate to true. But is this enough? No, this is now invalid SQL. No, this was not there. So this is invalid SQL. So what do? We comment it out. You see, it got commented out. So now what is the full query now? Select ID, users, blah, blah, blah. Our password is this. Of course, this is false. Or this is true. And we have an or. So we get true. The statement evaluates to true. Does it make sense? Amazing. Amazing. So we can just take this, what we just wrote, and an extra space for safety measure, because sometimes SQL is annoying. And hopefully now, if I do not get banned by iOS firewall, this should work. Okay, good. It worked. Now we have a second layer of injection. Okay, we see, okay, now we're logged in, beautiful, because it was just looking for a binary, like true or false. Now we see cities, we can search normally, of course, and we get results back, okay? But that's a different thing to get into. Let's just finish this challenge. Okay, so based on what we've seen in the previous input, we know that this is 95% vulnerable to the same SQL injection, same thing. But now here we have a different goal. We want to figure out the version of the database, like type of the database. And then maybe we want to figure out the tables that are in the database. And then maybe we can get the flag or maybe something else, whatever the goal is. So let's start breaking it. Okay, based on what you've seen before, we want to escape the quotation. Okay, now we're going to do a new operator. Okay, we're going to do the union operator. What is the union operator? Union SQL. Okay. Wow, it's even more complicated. Yeah, this is exactly what I mean. This. We're selecting column 1 and 2 from table 1. Union select some other column and another from another table. What is this doing? This is just putting them on top of each other. That's it. Like, honestly, nothing else. It's taking column 1 and 2, filling them here, the blue and the yellow and the blue, and then it's taking these two columns, the green and the purple, and just putting them below. That's it. So what do you notice here? The number of columns needs to match. You cannot union 2 columns with 3 columns. It will not know how to deal with it. So all we need to do is to match the number of columns. Okay, so let's test it. So let's do union, select. Now we don't know a table, so we're just going to select like fixed values, constant values, just for testing purposes. Union select 1 and 2 and 3. Why did I put 3 columns? Logically, looking at how we have 3 columns here, most likely the query happening in the background is also getting 3 different columns from the database. Okay, union select 1, 2, 3, and no need for defining a database unless you're dealing with Oracle. In that case, it's a disaster from the beginning أصلا that you're dealing with Oracle. It requires a valid table name. But yes, we're going to select. Now selecting all, we need to know a database first, a table first. So we're just testing if this works. Is this injectable? Let's see. Oh, beautiful. Now, of course, the first part did not match. But here we see that we get 1, 2, 3 back. So now we know that we're doing something correct. We know that we're doing something correct. So what's the next step? Next step is to try and figure out what type of database are we dealing with. Okay, now every database provider, for some reason, they have a different way of checking what version. Selecting 1, 2, 3. No, I'm not selecting columns. I'm selecting the numbers 1, 2, 3. Just like I can select right now some text. Okay, I'm not selecting the columns. No, I'm not even. I did not even specify from table. I'm just selecting those exact values, constant values, not variables from a database. Like it's literal string, literal integer. That's it. Okay. Now we want to get the version of the database. Different database providers have different ways of checking for the version. Okay, so we're gonna go through the most probable ones. Okay, it's most likely either MySQL, maybe Microsoft Server, or a very good chance it's SQLite. SQLite is a light version of SQL. Yeah, it's good. Okay, so we're just gonna do two, since you guessed it correctly. And it makes sense. It's a very simple website. Why do you need a whole server for the database? But now, this is how we check for MySQL. You do, let's replace it, this one. You do @ version. Why is it this way? I'm sorry. If I were to do it, I would not do it this way, but they did it this way. So this is now checking if this is MySQL. We get no response. Definitely this is not MySQL. But maybe SQLite. SQLite is a similar way you select, but now it's a different function. It's called SQLite _version. And then let's see. Beautiful. We get a response. We know for a fact, because God intended. Yes, that's all I can say. So now we know the version of the SQLite database. Do we care? No, but we know it's a SQLite database. So that's one of the ways to check of the type of the database. So why do we need this? Because every SQL provider has a different way of checking of the tables. So I want to check which tables exist. Well, it's different from each provider. So let's for the SQLite, let's try to wrap up SQLite table names very correctly spelled. Okay, Stack Overflow. This is when you're doing it from the CLI, but we want to do it programmatically. Yeah, this one is the one that worked. Select name from SQLite master. We don't even need this. It's not even needed. So name from SQLite master. So this special table in SQLite gives you information about everything there, the tables and other database stuff. Okay, so let's do comma union select name and SQL. I'll tell you what this is, and then just any number from this. What am I doing here? I'm selecting the name and the SQL syntax that was used to create the table. This will give us information about the columns inside the table. This is also another column in this table. So this is a special table. Okay, so we have name and then the query that was made to create the table from the special, very special table in SQLite. Okay. Okay, amazing. So let's see. Do we get some magical response? Beautiful stuff. We get hints table, more table, offices table, users table. So Let's see. Integer, blah, 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 and we see flag. Beautiful. We know we're in the right direction. Okay, so we know that the more table, okay, I'm sorry for the naming, but the more table has a flag column, which is text, which is exactly what we want. So what can we do? We can extract it. We can do an injection, union, select, flag, okay. Let's put anything, any numbers, we don't care. These are constants, from, what was the name of the table? More table. Okay, and then we do the comment. So we ignore everything else and we search. Amazing. We did an SQL injection. We get the flag. That's it. If you're here, you must have seen it. They have a hint, I think, or something. And this is the flag. That's it. It's an SQL injection. So it's a good practice for SQL injection. Yes, Ahmed.
Omar, do you mind rerunning the same SQL command that you just ran?
Yeah.
But instead of like random stuff 3, 1, 2, etc. Put the proper columns like ID and
What was the second column? Do you remember? Because if I go back, it will not let me. It will. Let's start with ID, for example.
I don't remember the other one. I just noticed ID.
Yeah, you still get the ID. Properly. Yeah. So it's a normal SQL query. It will work. If you put a variable, it will be rendered as a variable. If you just put a constant, it will just look at the constant and just return it repeatedly, like 3, 4, 2 in this case. Okay.
And last thing, why are we using union?
Because we have already a start for that query. We cannot change what came before. We can only change what came after. You get my point? Like there's already something here being selected, 3 columns being selected. We cannot change the fact that 3 columns are being selected from some table. We cannot change that. But we can add on top of it.
Yes. Makes sense.
Amazing.
Thank you.
And that wraps up our first proper SQL injection. Ali, do you have any question? Anything you would like me to elaborate on the SQL code? All good, amazing. Everything is good. Thumbs up, thumbs down. Okay, amazing. Okay, now sorry for the delay of 4 minutes. I hope you enjoyed, learned something new, and I think we are starting to ramp up the level of challenges here. So soon we will be testing out Banner. No, I'm joking. We will never do that.
And in 5 minutes, we're going to have the hackabox. So
Yes.
210 to 310. We're going to be taking a full, starting from just a single IP address. We're going to be seeing how can we enumerate, how can we scan, and how can we get a foothold on an entire machine. So stay tuned.
Wow, very interesting stuff. Now, just a small note, sadly did not have